For over half a century, scientists thought they had the story of black holes figured out. We believed. We knew how they were born, how they grew, and where they should be found. But the James Webb Space Telescope has just sent back data that could rewrite this entire chapter of cosmic history. It has revealed something that should unexist. A black hole so massive, so early in the universe, that it defies every rule. In our cosmic playbook today, we're going to unpack why this discovery has scientists stunned, what it means for our understanding of the universe, and why it might be the most important puzzle of modern astronomy. The mystery of impossible black holes. Black holes are usually born from the death of massive stars. When a star many times heavier than our sun exhausts its fuel, it collapses under its own gravity, creating a singularity, a region, where space and time themselves are crushed. These stellar mass black holes can weigh anywhere from a few to a few dozen suns. Over cosmic timescales, they can merge accrete gas and slowly grow larger. Eventually, after billions of years, they can become the supermassive black holes we see in the centers of galaxies today, monsters weighing millions or even billions of times the mass of the sun. That was the story. A slow, patient process of cosmic growth. But Webb has just shattered that narrative. Looking back to less than a billion years after the Big Bang, Webb has spotted supermassive black holes, already weighing hundreds of millions of solar masses. According to our models, they simply don't have enough time to get that big. Imagine meeting a newborn baby who is already 2 meters tall, fully grown, and demanding car keys. It should unhappen yet. In the young universe it did. Why this breaks the rules? The problem is speed. To grow to such immense sizes, black holes would need to consume gas and merge at the absolute theoretical maximum rate, known as the Eddington limit, continuously for hundreds of millions of years, without interruption. But that scenario is extremely unlikely. Gas is messy, chaotic, and often blown away by radiation and stellar W-ins. There's simply no way these early black holes should have had enough fuel or enough time. Yet Webb's infrared eyes have revealed them clearly. One of the most startling examples is a black hole found less than 700 million years after the Big Bang, weighing hundreds of millions of suns. Another candidate lurks even earlier. It forces us to confront a difficult truth. Either we're missing something fundamental about black holes, or our entire cosmological model is incomplete. Hypothesis 1: direct collapse. One of the most talked about ideas is that these black holes never formed from stars at all. Instead, in the dense gas-rich early universe, giant clouds of hydrogen might have collapsed directly under their own gravity into black holes, weighing tens of thousands of suns. From there, they could grow much faster, skipping the long stellar life cycle entirely. These so-called direct collapse black holes would be like cosmic shortcuts, fast-tracking the birth of monsters. Webb's discoveries lend strong support to this theory, but it still leaves unanswered questions. How often could such collapses happen? And why have we not seen more evidence of them? Hypothesis 2: dark matter's hidden role. Another possibility is that dark matter, the invisible scaffolding of the universe, may have played a more active role than we thought. Dark matter makes up roughly 27% of the cosmos, and while we can't see it directly, its gravitational influence is undeniable. If early dark matter clumps were unusually dense, they might have accelerated black hole growth, funneling gas rapidly into their cores. In this scenario, Black holes didn't tweak the rules. We just didn't know all the players in the game. But this would mean our current simulations of cosmic structure are missing a crucial ingredient. Hypothesis 3. The cosmological model is wrong. The most unsettling idea is that the standard model of cosmology itself, known as ΛCDM, might be incomplete. This model assumes a very specific timeline, galaxies forming slowly from the bottom up, with black holes emerging later as byproducts. But if Webb keeps finding more of these impossible giants, it could mean our assumptions about gravity, star formation, or even the physics of the early universe are flawed. Some theorists have gone as far as to suggest that our understanding of time is wrong. Understanding these anomalies could unlock new physics, reveal hidden forces, or even reshape our search for life in the cosmos. And there's another, more philosophical reason. These impossible black holes are reminders of how much we didn't know. They cosmic mirrors reflecting our own ignorance back at us. In a universe this vast and this strange, humility is the only rational response. The road ahead, so where do we go from here? Webb is just getting started. Future observations will target these mysterious black holes directly, probing their light, their surrounding galaxies, and their feeding habits. Projects like the upcoming extremely large telescope on Earth and NASA's next generation observatories will add space, and expansion may need a radical revision. That's not just tweaking equations, that's rewriting the origin story of the cosmos. The bigger picture, what makes this discovery so profound, is not just the black holes themselves, but what they represent. Every time we thought we had the universe figured out, reality has humbled us. First, we thought Earth was the center of everything. Then we realized our sun was just one star in a galaxy of hundreds of billions. Then Hubble showed us there are hundreds of billions of galaxies. Now Webb is showing us that even our most cherished models of cosmic evolution may be too simple, and it's not just black holes. Webb has already found galaxies that are too big, too bright, too chemically evolved for their age. Combine those discoveries with these impossible black holes, and the message is clear. The universe hit the ground. Running, it was unta slow. Steady dawn, it was a cosmic firestorm, building massive structures far earlier than anyone thought possible. Why this matters for us? It might seem like an abstract problem. Why should we care if black holes grew faster than expected 13 billion years ago? But discoveries like this ripple through science. If the standard model of cosmology needs rewriting, then our predictions for the universe's fate, the behavior of dark matter, even the formation of our own Milky Way could all be even more pieces to the puzzle. Together, they may finally reveal whether direct collapse, dark matter, or something even stranger gave birth to these monsters. But make no mistake, whatever the answer is, it will reshape our understanding of the universe. Closing thoughts. So has Webb just broken cosmology? Not quite, but it has cracked the foundation, and through those cracks, the light of discovery is pouring in. The impossible black holes are not the end of science. They are the beginning of a new chapter. What do you think? Are these black holes proof that our theories are wrong? Or are they just nature's clever shortcuts? Drop your thoughts in the comments. We'd love to hear your take. And if you want to follow every twist and turn of this cosmic detective story, make sure to subscribe, hit the notification bell, because with Webb, the surprises are only just beginning. What do you think? Are these impossible black holes proof our theories are wrong? Or are they just nature's clever shortcut? Drop your thoughts in the comments. We'd love to hear your take. And if you want to follow every twist of this cosmic detective story, make sure to subscribe and turn on notifications. Because with Webb, the surprises are only just beginning.